Hello everyone, welcome to today's session in your CAT Edge program. So today we are working on time, speed and distance. So in today's session we are covering all the foundation on time, speed and distance. So this is one of the important chapter in your quantitative aptitude. And definitely you will have one or two questions from this time, speed and distance in your examination. So before going to the higher level examination, so in today's session we are going to cover all the fundamentals so that you can be able to apply this fundamental learning on the higher level questions. So the chapter is time, speed and distance, right? So what is the relation between among these three? Among time, speed and distance, what is the relation? So distance covered is given by speed into time, as all of you know. Distance is equal to speed into time, right? Distance covered is equal to speed into time. For example, with a speed of 20 km per hour, in 2 hours, how much distance can be covered? 20 into 2, which is 40. So distance is equal to speed into time. So here speed is equal to distance divided by time, and similarly time is equal to distance divided by speed. So what are the units of speed here? The units of speed are kilometer per hour or meters per second. Okay, kilometer per hour or meters per second. So what is the relation among these? How to convert kilometer per hour into meters per second? So 1 kilometer per hour is equal to 5 by 18 meters per second. So to convert kilometer per hour into meters per second, we have to multiply it with 5 by 18. To convert meters per second into kilometer per hour, we have to multiply with 18 by 5. So conversion of speed from kilometer per hour to meter per second and meter per second to kilometer per hour. One has to be comfortable with this also whenever you are working the questions. Okay. Now, so distance is equal to speed into time. So speed in kilometer per hour and or meters per second, and time would be in hours or in seconds, right? So according to the conversion we have to use. Okay. Now, so remember, always distance traveled is equal to speed into time. This speed, for example, see, a person covers the total distance d with a speed of s in time t. Then we write d is equal to s into t. Here s is the uniform speed. Here speed can be uniform speed or average speed or relative speed. So what is this uniform speed, what is this average speed, and what is this relative speed? So if the object covers the total distance with a single speed, then that speed is what? Uniform speed. For example, now next is average speed. What is average speed? Average speed is nothing but total speed. Average speed means total speed. total speed. So what does it mean? See, this is the total distance to be covered, let us say. Okay, this total distance, let us say the first half d by 2, second half d by 2. The first half is covered with a speed of x kilometer per hour, and the second half is covered with a speed of y kilometer per hour. Then what is the average speed? Average speed means what? Average speed means, as I said, total speed. Total speed means total distance. Total distance by total time. Total time. So if you observe here, total distance covered is nothing but d by 2 plus d by 2, which is d. And time taken to cover first half with a speed of x is d by 2 by x. Time taken to cover this first half is distance by speed, plus time taken to cover second half is d by 2 by y. If you simply simplify this, you will get 2xy divided by x plus y kilometer per hour. Kilometer per hour. If the total distance is made into two equal parts, and those distances are covered with the speeds of x kilometer per hour and y kilometer per hour, then the average speed is given by 2xy divided by x plus y. For example, instead of two equal parts, if the total distance is made into three equal parts, d by 3, 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 with the speeds of x, y and z, then what would be the average speed? In this case, the average speed is given by, see, if you apply the same procedure, average speed is equal to total distance by total time, you will get 3xyz by xy plus yz plus zx kilometer per hour. Okay, so the total distance divided into two equal parts, total distance divided into three equal parts. For example, the total distance, see, third case I am taking, the total distance is made into two parts. Okay, the first part is covered with a speed of x kilometer per hour, and the second part is covered with a speed of y kilometer per hour, and the distances covered d1 and d2 here is in the ratio m is to n. Total distance is d1 plus d2. So this distance and this distance covered are in the ratio m is to n. In that case, what is the average speed? In this case, the average speed is given by m plus n into xy, m plus n into xy divided by my plus nx, my plus nx kilometer per hour, kilometer per hour. The total distance divided into two parts. Those two parts are in the ratio m is to n, and those two parts of distances are covered with speed x and y. Then the combined speed, average speed, is given by m plus n into xy divided by my plus nx. This is about average speed. Average speed means, simply remember, average speed means total speed. Total speed means total distance by total time. So different cases are given. The total distance made into two equal parts, three equal parts, any two parts. Okay, any two parts. So like that, various applications we have discussed on average speed. Always remember, distance is equal to speed into time. That speed can be uniform speed, average speed, or relative speed. Already we have discussed about uniform speed and average speed. Now next is the concept of relative speed. is relative speed? The speed of one object with respect to the other. The speed acquired by an object to attain the speed of the other is known as relative speed. When two objects are moving in the same direction, when two objects are moving in the same direction with the speeds x and y, with the speeds x and y, x kilometer per hour and y kilometer per hour, where x is greater than y, then relative speed is given by x minus y kilometer per hour. When two objects are moving in the same direction, this is with a speed of x and one more with a speed of y. Okay, so if x is greater than y, the relative speed is given by x minus y kilometer per hour. The greater speed is x, the lesser speed is y here. Okay, two objects moving in the same direction. If for example two objects are moving in the opposite direction, if two objects are moving in the opposite directions with the speeds of x kilometer per hour and y kilometer per hour, if two objects are moving in opposite directions with the speeds of x kilometer per hour and y kilometer per hour, then what is the relative speed? The relative speed would be x plus y kilometer per hour. So when relative speed, the concept of uniform speed comes when only one object, one speed. The concept of average speed arises when you have one object covers the distance with multiple speeds. Relative speed arises when different objects traveling with different speeds. Different objects, different speeds may be in the same direction or in the opposite direction. This is the basic of your time and distance about what is time, what is distance, and what is speed, and what are different types of speed. Now application of time, speed and distance on trains. Application of time, speed and distance on trains. First one. In this first one, see, this is a train. This is a train. A train of length LT. A train of length LT. It is a tree or a man. So what is happening here? A train crossing a man. A train crossing a tree. When a train crosses a tree or a man or a pole which is of negligible length as compared to the length of the train. A train crossing a pole means the last part of the train has to cross the pole. A train has to cross a man means the last part of the train has to cross the man. So it has to cover its own length. So when a train passes a man or a pole or a tree, then the distance covered by the train is its own length, length of the train. Length of the train. Okay, length of the train. Next, second case. There is a train of length LT and there is a bridge. There is a bridge or a tunnel or a platform whose length is LB. Okay, so a train crossing a bridge. A train crossing a bridge means the train will be coming here, right? A train crossing a bridge. A train crossing a bridge means this train is crossing the bridge. Crossing the bridge. A train to cross a bridge, it has to cover the distance equal to the length of the bridge and its own length. So in this case, the distance covered by the train to cross a bridge or a tunnel or a platform is length of the train and length of the bridge. The distance covered by a train to pass a man or a tree or a pole is its own length. The distance covered by a train to pass a platform or a bridge or tunnel is equal to the sum of the lengths of the train and the platform or bridge or tunnel. Next, a train of length L1 is passing another train of length L2. Okay, a train of length L1 is passing another train of length L1, whether they are moving in same direction or in opposite direction. A train to pass the other train completely, the distance covered by each train is equal to sum of the lengths of both the trains. The distance covered by a train to pass another train completely is sum of the lengths of both the trains. Next, there is a faster train. There is a faster train whose length is LF, and there is a slower train. Inside this slower train there is a man. There is a man. Okay, there is a man. So the distance covered by the faster train to cross a man in the slow train, to cross a man in the slow train, it is nothing but a train crossing a man, whether he is in a bus or a train or whatever it is, or in standstill position. Okay, so see here, a train, a faster train crossing a man in the slower train, then the distance covered by the faster train is equal to length of the faster train. Length of the faster train. So here once again see, the first case is a train passing a tree or a man or a pole, a train passing a platform, a train passing another train, a train passing a man in the other train. In this case, the distance covered is equal to length of the faster train. Length of the faster train. Okay. Right. So application of time, speed and distance and trains, the basic introduction we have done. Now application of time, speed and distance on boats and streams. On boats and streams. Please see here. Application of time, speed and distance on boats and streams. Some basic terminology here you need to understand. Boats and streams. So there are two kinds of motion in the stream. One is the upstream motion, the other is downstream motion. So what is downstream motion and what is upstream motion? If the boat moves along the stream, if the boat moves in the direction of flow of river, it is called downstream motion. If the boat moves against the flow of river, it is called upstream motion. So downstream motion and upstream motion. So in the direction of flow of river, if the boat is moving, it is called downstream. If the boat moves against the flow of river or stream, it is called upstream motion. Okay. Now see some terminology as I have said. So first one, the speed of boat or man, speed of man or boat in still water, speed of man or boat in still water, if it is x kilometer per hour, and speed of stream or speed of flow of river or speed of current, all are same terms. Speed of current is y kilometer per hour. Then downstream speed ds is given by x plus y kilometer per hour, and upstream speed us is given by x minus y kilometer per hour. So here see, downstream speed is x plus y and upstream speed is x minus y. So when x and y are known, you can find ds and us. When speed of man or boat in still water, speed of stream, both x and y are known, ds and us you can find with the formula x plus y and x minus y. Similarly, when ds and us are given, then also you can find x and y. So x is nothing but speed of the man or boat in still water. It is ds plus us by 2. Downstream speed plus upstream speed divided by 2 is x. Y is ds minus us by 2. So downstream speed, upstream speed, if you know, you can find speed of the man or boat in still water and speed of stream. If speed of the man or boat in still water and stream are given, you can find downstream speed and upstream speed with the given formula. This thing also you can remember. Okay, so downstream motion, what is downstream motion, what is upstream motion? Okay, for example, this is the flow of river. If the boat goes in this direction, it is downstream. If the boat moves in this direction, it is upstream. Okay, I hope it is clear about the boats and streams. So application of time, speed and distance on boats and streams and trains we have done. Whatever the other applications we will get, we will solve in our, we will do workout on problem solving. Okay, and we will learn that. So see what we have discussed in the introduction. What is the relation between time, speed and distance? What are the units of speed, time and distance? And what are different kinds of speed? Uniform speed, average speed and relative speed. When those concepts arises, and application of time, speed and distance on trains and boats and streams we have discussed. Now see here. Let us work on the questions. Please see here. A man is running at a speed of 36 km per hour. 36 km per hour, convert kilometer per hour into meters per second. So I can convert kilometer per hour into meters per second. How can I convert kilometer per hour into meters per second? I already told you. To convert kilometer per hour into meters per second, multiply with 5 by 18. 5 by 18. So 18 2s are 36. Thereby 2 5s are 10 meters per second. 10 meters per second. So the speed is 10 meters per second. Then how many meters does he cover in 40 seconds? Distance covered in 40 seconds. Distance is speed into time. Time is 40, speed is 10. 10 into 40 is 400. So 400 meters is the answer. So option 1 is correct. Next, the speed of a train is 20 meters per second. The time it takes to cross a telephone pole is 10 seconds. Then find the length. I already have told you just now, explained you. So what is happening here? A train crosses a telephone pole. When a train crosses a telephone pole, the distance covered is nothing but its own length. Its own length. So to find the length of the train, we need to find out the distance covered. Distance is nothing but speed into time. Speed is given as 20 meters per second and time taken is 10 seconds. So 20 into 10, which is 200. So 200 meters is the distance covered. The distance is itself length of the train. So I hope it is clear. So answer is 200 meter. Now next, third question. A train of length 400 meter traveling with a speed of 15 meters per second crosses a platform in 1 minute. In 1 minute means 60 seconds. Okay, what is the length of the platform? So when a train crosses a platform, the distance covered is equal to length of the train plus length of the platform. Yes or no? And here distance is speed into time. Speed into time. So how much time it has taken? 1 minute to cross the platform. Speed is 15. So 15 into speed into time is equal to length of the train is 400 and length of the platform is not known. Therefore, length of the platform is equal to 15, 60 is 900. 900 minus 400, which is 500. So answer is 500 meter. Answer is 500 meter. So option B is the correct answer. Next, speed of the train is 88 km per hour. So what time will it take to cross a platform of 180 meter long if the length of the train is 150 meter? So a train crossing a platform, the distance covered is equal to sum of the lengths of the train and platform. It is given that the length of platform is 180 and length of train is 150. Okay, and speed is given as 88 km per hour. Convert into meters per second by multiplying with 5 by 18. Distance is speed into time. How much time will it take? So if you simply apply this, how much you are going to get? T is equal to 180 plus 150 is 330 into, it is how much? 330 into 18 divided by 88 into 5. So how much you are going to get? 566 are 11 8s are 11 6 are. Now if you see here, it is 2 4s are 2 9s are 4 into 1.5. 4 into 1.5 is 6. 9 into 1.5 is 13.5. So it will take 13.5 seconds. So answer is 13 and half seconds. Distance covered is equal to sum of the lengths of train and platform. These two together is 330. Distance is speed into time. From this you got time as 13.5 seconds. Next, fifth question. A certain distance is covered at v km per hour. If half of the same distance is covered in double the time, then the ratio of the former's speed to that of the latter speed. Please understand what's given. Please understand here. Distance is nothing but speed into time. Distance is nothing but speed into time, right? So here what is given, please see the same distance is covered, so distance is constant. When distance is constant, speed and time are inversely proportional. Speed and time are inversely proportional when d is constant. If half of the same, so sorry, here the distance is not constant. What is given here? Distance is not constant. Distance is half. Yes or no? D is equal to S into T. D is equal to S into T. If half of the same distance is covered in double the time, half of the same distance is covered in double the time, then what you are going to get, if this is S, this is some new speed, okay, new speed. So what will you get? This by this. So dt cancel. So you will get 2 is equal to, please understand here, initial speed by, this is S1, I am taking this one as S2. T cancel. Thereby you are going to get S1 by S2. S1 by S2 as 4:1. 4:1. S1 by S2 is 4:1. So what is asked here? Then the ratio of the former speed, initial speed to the later is 4:1. So answer is A. Answer is A. Next, question number 6. A person can row a distance of 1 kilometer upstream in 10 minutes. 1 kilometer upstream in 10 minutes. And downstream in 4 minutes. Then what is the speed of the stream? So 1 kilometer in 10 minutes. 10 minutes means how much? 1 by 6 hour. 4 minutes means what? 1 by 15 hour. Okay, so 1 kilometer able to be traveling in how much time? 1 by 6 hour. Thereby upstream speed would be upstream distance by upstream time. So it is 6 kilometer per hour is the upstream speed. Similarly, downstream speed, 1 kilometer in 1 by 15th hour. So 15 kilometer per hour is the downstream speed. Downstream speed and upstream speed we have got. So ds and us we have got. Now we need speed of the stream. Speed of the stream means y. So y, how do we get? Y is ds minus us by 2. I already given the formula. So ds is already calculated as 15 and us is 6 divided by 2. So 9 by 2 is 4.5 kilometer per hour. So 4.5 kilometer per hour is the answer. Next, question number 7. Anil calculated that he will take 45 minutes to cover a distance of 60 kilometer. So what is the speed of what is the initial speed? 60 kilometers in 45 minutes means 3/4 hour. 45 by 60 hour. So the speed would be 80 kilometer per hour. So actually his initial speed is 80 kilometer per hour when he is covering 60 kilometers in 45 minutes. Now the question is, how long will it take to cover the same distance if the speed of the car is reduced by 20 kilometer, when it is reduced by 20 kilometer per hour, then the new speed is 60 kilometer per hour. So how much time will it take to cover 60 kilometers with a speed of 60? So it will take 1 hour. It will take 1 hour. So answer is 60 minutes. Next question number 8. A car travels from Patna to Jehanabad at a speed of 65 km per hour in 1 hour. Okay, in 1 hour. If the speed is reduced by 15 km per hour, then how much more time will it take to cover the same distance? When the distance is constant, speed and time are inversely proportional. Speed and time are inversely proportional. So speed is initially 65. If it is reduced by 15 km per hour, it becomes 50. Thereby initial ratio of speeds is 13:10. 13:10. So times ratio would be 10:13. 10:13. And this 13, this 10 parts is given as 1 hour, means 60 minutes. If 10 parts is 60 minutes, in this case it will take how much time? 10 into 6 is 60. 13 into 6 is 78. So answer is 78 minutes. So he is asked how much more time it will take. So here it is taking 60 minutes. Here it is taking 78 minutes. So how much extra time? More 18 minutes. More 18 minutes. So answer is option C. Next question number 9. In a kilometer race, A beats B by 10 meter. In a 2 kilometer race, A beats B by how many meters? So it's very simple question. See, A beats B for in a 1000 meter race. A beats B by 10 meters. So in a 2000 meter race, A beats B by how many meters? 20 meters. 20 meters. So answer is 20 meters. Answer is 20 meters. Question number 10. A train 225 meter long is running at 45 km per hour. In what time does it cross a man running at 80 km per hour in the same direction? So a train crossing a man, but the man is not in a standstill position. He is also running at the speed of 18 km per hour. So here the distance covered by the train is equal to its own length. Length of train. Distance is equal to length of train. Here distance is speed into time. It has in what time he is going to cross, we have to find out. Length of the train is already given as 225. Speed into time is distance. The distance is equal to length of the train. The length of the train is already given as 225. Here speed means what? Two objects, train and man. So we apply relative speed. Both are moving in the same direction. So see here, one is 45, the other is 18. Both are moving in the same direction. So x minus y, it is in kilometer per hour. So convert into meter per second by multiplying with 5 by 18. So it is 27. 9 3s are 9 2s are. So 3 5s are 15. 15 15s are 25. Thereby time taken is 2 into 15, 30 seconds. So answer is 30 seconds. Question number 11. Question number 11. See, two trains started from a station. at the same time in the same direction at the speeds of 70 kilometer per hour and 60 kilometer per hour. What will be the distance between them, between the two trains after 6 hours? After 6 hours, distance between them after 6 hours. In 1 hour, one train is covering how much? 10 kilometer per hour more. In 6 hours, 10 into 6, which is 60 kilometer. Distance is equal to always speed into time. Time is 6. Here speed means relative speed. Both are traveling in the same direction. So 70 minus 60, which is 10. So thereby distance is speed into time. Here time is relative speed, x minus y. So thereby the answer is 60 kilometer. 60 kilometer. So all these are basic questions to build your foundation now and your basic, to make your basics strong. You have to understand. Okay. Now question number 12. A man can row half kilometer against the current in 12 minutes. Against the current means, against the stream means upstream. So upstream speed would be distance by time. Distance by time is 1 by 5 hour. Half kilometer means it should be in hours. 12 minutes means 12 by 60 minutes. Thereby it is nothing but 5 by 2, which is 2.5 kilometer per hour. And it returns in 6 minutes. And returns in 6 minutes. Thereby downstream speed, the same half kilometer, 6 minutes means 1 by 10. 1 by 10 hours. Thereby 10 by 2. 10 by 2 means how much? 5 kilometer per hour. So downstream speed is 5 kilometer per hour. Upstream speed is 2.5 kilometer per hour. What is the speed of current? Current means Y. Y is, as I already gave the formula, according to that, ds minus us by 2. 5 minus 2.5, which is 2.5 by 2. 2.5 by 2 is 1.25. 1.25 kilometer per hour is the speed of the stream, which is option A. Now next, question number 13. In a kilometer race, Amit beats Bahadur by 100 meter and Bahadur beats Chandra by 200 meter. In how many meters does Amit beat Chandra in the same race? So please understand here, Amit and Bahadur. Amit beats Bahadur by 100 meter. Means if it is 1000, it is 900. Similarly, Bahadur beats Chandra by 200. If it is 1000, it is 800. Okay. Now, if you observe here the ratio is 10:9, A is to B. Here the ratio is 5:4. So what will you get? A is to B is to C. So first see, A is to B is 10:9. A is to B is 10:9 and B is to C is 5:4. So from this I will get 10 into 5, 50, 9 into 5, 45, 9 into 4, 36. So this is A, this is B, this is C. So what does it mean? If A is reaching 50, C is reaching 36. So in a 50 meter race, A beats C by 14 meter. So in a 1000 meter race, how much? 50, 14, 128, 1280. So answer is 280 meter. So answer is 280 meter. I hope it is clear. It's an important model. Okay. Next question number 14. On a river, Q is the midpoint. Q is the midpoint between the 2 points P and R on the same bank of river. On the same bank of river. A boat can go from P to Q and back in 12 hours. From P to R in 16 hour 40 minutes. 16 hour 40 minutes. How long would it take to cover to go from R to P? To go from R to P. See here what is given. It takes this is P, this is Q, this is some R. Okay, from here to here, from here to here. So what is given here? Q is the midpoint between P and R. So a boat can go from P to Q and back in 12 hours. Back in 12 hours. Back in 12 hours. From P to R. From P to R in 16 hour 40 minutes. 16 hour 40 minutes. So what does it mean? It takes 8 hour 20 minutes and it also takes 8 hour 20 minutes. Okay, because it is the midpoint and it is so say what is given. A boat can go from P to Q and back. P to Q and back. Similarly, Q to R and back in 12 hours. So from here to here it is taking 8 hour 20 minutes. From here to here it is taking 8 hour 20 minutes. So in the reverse, in the return it will take how much? 12 minus 8 hour 20. 8 hour 20 minutes. Which is nothing but 3 hour 40 minutes. Here also same. Here also same. 3 hour 40 minutes. 3 hour 40 minutes. Thereby, how long will it take to go from R to P? From R to P means this is 3 hour 40. This is 3 hour 40. Total 3 hour 40 minutes into 2. 3 hour 40 minutes into 2, which is nothing but 7 hour 20 minutes. 7 hour 20 minutes. So answer is 7 1 by 3. 7 1 by 3. 7 hour 20 minutes. 7 hour 20 minutes. 7 1 by 3 is the answer. So what is the answer here? None of this. Now question number 15. Question number 15. Two trains are running on parallel lines in the same direction at the speeds of 50 and 30 respectively. The faster train crosses a man in the slower train in 18 seconds. When a faster train crosses a man in the slower train, the distance covered is equal to length of the faster train. Length of the faster train. So to find the length of the faster train, you need distance. Distance means what here? Speed into time. Speed is what here? Speed is relative speed. Both are traveling in the same direction. So thereby it is 50 minus 30. It is in kilometer per hour, converting into meters per second. Distance is equal to speed into time. Time is given as 18. So thereby 18 cancel. 50 minus 30, 20 into 5, which is 100 meter. Thereby the length of the faster train, which is equal to the distance covered, speed into time, which we got as 100. So answer is option B. Then next, question number 16. Question number 16. Please see here. A car driver. Question number 16. A car driver travels from the plains to the hill station, which is 200 km apart, at an average speed of 40 km per hour. So in the return trip, he covers the same distance at an average speed of 20 km per hour. The average speed of the car over the entire distance of 400 kilometers. So he is going from one place to A to B. He is going from A to B and then again coming from B to A. B to A. So if this is some d by 2, this is some d by 2, total distance is d is made into two equal parts. The first part with a speed of 40 km per hour, okay, and the second part with a speed of 20 km per hour. So what is the average speed? What is the average speed? It is already calculated as 2xy divided by x plus y. So 40 plus 20 is 60. 60 means 23 times. 2 into 40, 80. 80 by 3. 80 by 3 means how much? 26.66 kilometer per hour. So answer is option B. Question number 17. What is the answer here? Question number 17. The average speed of a train in the onward journey is 25% more than that in the return journey. The train halts for 1 hour on reaching destination. The total time taken for the complete to and fro journey is 17 hours. 17 hours, covering a distance of 800 kilometer. 800 kilometer. The speed of the train in the onward journey. Onward journey. Please see here the average speed of the train in the onward journey is how much? 25% more this distance and the return journey, both are same. So here distance traveled, distance is same, distance is same, distance is constant, distance is constant, and here the speed, and here the speed in the ratio 5:4. S1 is to S2 is 5:4. Thereby times taken will be in the ratio 4:5. 4:5. Yes or no? Times taken will be in the ratio 4:5. Now please see here. Now what is the question asked? The train halts for 1 hour on reaching destination. The total time taken for the complete to and fro journey is 17 hours, covering a distance of 800 km. The speed of the train in the onward journey. So what would be the speed of, see the total time taken is how much here? The total time taken. See here, this is 400 kilometer. This is also 400 kilometer. Okay. So thereby it is given that this is 4 parts. To understand, here the speed is 25% more than this speed. The train, the onward journey is 25% more than the return journey. If this is the return journey, this is the onward journey. This speed is 125, this is 100. So speed's ratio is 5:4, times ratio is 4:5. And the train halts for 1 hour on reaching destination. The total time taken for the complete to and fro journey is 17 hours. So 17 minus 1, 16 hours is the total time taken. Thereby 16 hours is the total time taken means 9 parts. 9 parts is 16 hours. 9 parts is 16 hours. So what would be 4 parts? 4 by 9 into 16. This is 5 by 9 into 16. Okay. Now what is asked here? The speed of the train in the onward journey. The speed of the train in the onward journey means S1. S1 is equal to distance by time. Time here is onward 4 by 9. 4 by 9 into 16. So how much you are going to get? 16 25s are 400. 25 9s are 225. 225 by 4. 225 by 4. Speed is equal to distance by time, right? 225 by 4 means how much here? 56.25. 56.25. So answer is 56.25 km per hour. Now question number 18. Walking at 6/7 of usual speed, a man is 12 minutes late. Find the usual time taken to cover the distance. So distance is constant. When distance is constant, speed and time are inversely proportional. So walking at 6/7 of usual speed. The usual speed is 7. He is walking with now 6 parts of that speed. So the speeds are in the ratio 7:6. Original speed, the walking speed. So the times taken will be in the ratio 6:7. 6:7. If speeds are in the ratio 7:6, times taken will be in the ratio 6:7. So initially if it is taking 6 parts time, now it is taking 7 parts time. So it takes 1 part more. That 1 part is given as 12 minutes. 12 minutes late means more. So that 1 part extra means that 1 part is 12 minutes. If 1 part is 12 minutes, then the usual time is how much? 6 parts. If 1 part is 12 minutes, then 6 parts would be 72 minutes. So answer is 72 minutes, which is 1 hour 12 minutes. 1 hour 12 minutes. Now question number 19. A car covers a distance of 715 kilometers. 715 kilometers at a constant speed. If the speed of the car would have been 10 kilometers per hour more, then it would have taken 2 hours less. 2 hours less to cover the same distance. So what is the original speed of the car? So it is nothing but 715 by actual speed. 715 by s plus 10. So time taken in the first case with the normal speed, time taken when the speed increased by 10 kilometers per hour, the difference is 2 hours. So which equation is going to satisfy? Which value of s? Which value of s is going to satisfy? So see here, 45, if I keep here, 45, 1s are 45, 265, not divisible. If it is, for example, 50 not divisible. If I keep 55, 1s are 55, s is equal to 55 if I keep, then what will I get? 715 by 55 minus 715 by 55 plus 10, 65. It is nothing but 55 1s are 55, 16 3, 55 3s are 13 minus 65 11s are 13 minus 11 is 2, satisfied. So answer is S is 55. So solving this through options is a better choice. Otherwise you have to form a quadratic equation and then you have to solve, which is not recommendable in the competitive exam. Go through options and verify and get the answer. Now question number 20, the last question for today's session. So please see here, a train M leaves Meerut at 5 a.m. and reaches Delhi at 9 a.m. Another train leaves Delhi at 7 a.m. and reaches Meerut at 10:30. So it is taking 4 hours. It is taking 3.5 hours. 3.5 hours. Right? So I am considering the distance. I am considering the distance between Meerut and Delhi at 140. By 140, sir? By 140 means whatever the figure I take, it should be divisible by 4 and 3.5. Thereby I will get the speeds in integers. So speed of first train and speed of second train. Okay, so for that purpose, so speed of first train is how much? 140 by 4, which is 35 km per hour. 140 by 3.5 is 40 km per hour. So by the time the second train started at 7 a.m. from Delhi, the first train already covered 2 hours. Already covered 2 hours. So 2 into 35, 70 kilometer. Now this train at 7 a.m. is here, 70 kilometer away from Meerut, and it has the second train with a speed of 40 has started from Delhi. Now this is at 7 a.m. This is at 7 a.m. This is with a speed of 35 kilometer per hour. Now the question is, at what time, how much time it will take for both the trains? Both the trains are moving in the opposite directions. How much time will it take? Time is equal to distance by speed. The relative distance between them now is 70. If it is 70, this total is 140, thereby it would be 70. So 70 by relative speed, 35 plus 40, 35 plus 40, which is 70 by 75, 75 hour, converting to minutes. So how much time will it take? If you observe here, 15 5s are, 15 4s are, 5 14s are. So it will take 56 minutes. It will take 56 minutes from 7 a.m. Thereby 7 hour 56 minutes. So at 7 hour 56 minutes a.m. the both trains will pass each other, will cross each other. So answer is option A. Option A. I hope it is clear. Okay. So this is the basic exercise on time, speed and distance what we have done today. And in our next class, that is tomorrow, we are going to have higher level questions in time, speed and distance. So don't miss tomorrow's session. Thank you so much for watching the video.